Hi everybody, it's Mrs. Cassell. I wanted to walk through the physics scenario that you were given for how to find the velocity of your roller coaster at some point along its path. So I'm going to work through the process that is in the notes in the Nearpod, and then also how to arrive at the solution for the multiple choice question that's in there. So if I remember right, the roller coaster, it has some sort of look like this, right? It's I guess I could draw the end there, like a human being instead of, like, I don't know, a human being who can't draw. So worse, some of you are going, no, blend the line, blend the line. Okay, so we've got our roller coaster up here at the top. It is going to go down the slope, and then right at the bottom is where I wanted to know what is the velocity at this position. We know a couple things about this problem. We know that there's 50 meters right here and just 10 meters between the ground and the roller coaster track right there. We also know that the mass of the roller coaster, I believe, was 200 kilograms. It's a small roller coaster. So that's the information that we have. Oh, and we have one other number that we always know, right? The acceleration of gravity is 9.8 meters per second squared. So here's the big idea, right? If we think about what's happening, the total energy at the top is equal to the total energy right here, is equal to the total energy over here, right? At any given point along our track, the total amount of energy is equal. How do we find the total energy? We call that mechanical energy. That's equal to our gravitational potential energy plus our kinetic energy. If this was a chemical reaction or if there was nuclear power, there'd be other kinds of energy that we would possibly need to include, but not this time. We're just looking at these forms of energy because that's all that's at work here to power this roller coaster. So there's a couple other things that we know about a scenario like this. At the very top of the roller coaster, right up there, at the very top, the velocity is 0. Well, if kinetic energy is 1/2 times mass times velocity squared, if I have a velocity of 0, then that means I have no kinetic energy. So that's a really helpful thing for us to know. At the very top there, when we want to figure out what's the total energy, the only option we have is gravitational potential energy. That's mass times the acceleration of gravity times the height the object can fall. So at the very top, we have only gravitational potential energy. So that's going to be equal to the mass of our roller coaster, 200 kilograms, times the acceleration of gravity, 9.8 meters per second squared, times the height that we are above the ground, 50 meters. When I plug all those numbers into my calculator, I get 98,000 joules of energy. So, thinking back to my equation from a second ago, my total energy, right? That's what mechanical energy is. That's the total energy. That's what we're talking about here. My total energy is my gravitational potential energy plus my kinetic energy. In this case, I had 98,000 joules of gravitational potential energy plus 0 joules of kinetic energy. So my total energy at any given point along this roller coaster is 98,000 joules. So that's the first step of our problem solving process here, is to figure out what that total mechanical energy is, and in this case, it's 98,000 joules. My next step in this process is to basically do the same thing at the point on the roller coaster that I'm curious about. Because here, I know that I've got some kinetic energy and I've got some potential energy. What I really want to know is velocity, right? So I'm really trying to figure out what is that kinetic energy at that spot, because that's what's going to allow me to find velocity. But I also know that my total energy at any given point are these two things added together. So I know my total energy, but I better find my new gravitational potential energy and then my kinetic energy for this to work. Oh, good. This is working. Had to double check. So here we go. The next thing that we're going to do. I've got step 2. I'm going to find the potential energy at that new spot on the roller coaster. So the gravitational potential energy at spot question mark. It's the same equation, but this time I've got a different height. So when I plug in my h, it's not going to be 50. This time it's going to be 10. And now I get a number like 19,600 joules. Well, I know a couple things here. I know that my total energy is equal to my gravitational potential energy plus kinetic energy. So with a little bit of algebra, I can get that kinetic energy by itself, because that's how I'm going to find velocity. So my kinetic energy is going to be equal to my total mechanical energy minus my new gravitational potential energy at my spot that I'm curious about. So this means I'm going to take 98,000 joules, because that was my total mechanical energy, minus 19,600 joules. And I get a number which is 78,400 joules. That's my kinetic energy. So I'm just going to highlight that with a box that's a little bolder. I've just figured out what the total energy of motion is for my cart at this spot. Now, if I'd been really clever, I would have made a page that could scroll here, you guys, so that way I could just, carry on with what we're doing. But I'm going to have to go on and add a new page to do that. So I'm going to go ahead and close that for a second. Not now. There we go. I'm going to add this. And I'm afraid I super appreciate having graph paper. Sometimes I don't know how I live a life without it. So, oops, there we go. So now we're ready to figure out what that tells us about our velocity. So in class, one of the things that was in your notes was that I told you you could use this equation instead. I'm going to work through that really quickly right now, just so you could see the algebra for where that came from. I'm trying to solve for v. I've got a squared in the way, I've got a 1/2, I've got an m in the way. So the 1/2, let's start with that. I'm going to multiply both sides by 2. Let's see, inverse. It's going to get rid of my 1/2. 2 kinetic energy is equal to mass times v times, mass times velocity squared. Well, now I've got this m that's bugging me. So I'm going to divide both sides by m. I'm doing that because it's m times velocity squared. That gets rid of that m. Now I've got 2 kinetic energy divided by mass equals velocity squared. Well, now that squared is really bringing me down. So I'm going to take the square root of both sides there. That takes care of my squared. And I have that velocity is equal to the square root of 2 times my kinetic energy divided by mass. But on the last page, I figured out that we can at least keep some of the colors the same. I figured out that my kinetic energy was equal to 78,400 joules. I know my mass is 200 kilograms. And those are the only numbers I need. I'm going to plug those numbers in right here and then use my calculator to tell me what that velocity is. I've got 2 1,400 joules divided by 200 kilograms. It's really important when you do a problem like this. What's inside your parentheses or inside your radical here, you need to do this first. If you're like me and you end up using your phone as a calculator, make sure you press the equals button before you do a square root. Your calculator isn't as smart as you are. It's not going to be able to make decisions. So it's going to follow the order of operations. And it's going to say a square root is way more interesting than multiplication and division. And it's going to do that first instead of doing the way you want it to. So you're going to plug those numbers in your calculator. And once you do that, you get that the velocity of your roller coaster is 28 meters per second. That's a little over highway speed. That is a fast roller coaster. That would be one you would be thrilled to come sliding down a ramp on and then be going as fast as a car speeding down the highway. All right, I hope this helps everybody figure out what's going on here. And thank you, everybody. Good luck.